Hello, everyone. Thank you for joining us today. B9 Creations is incredibly excited to host this panel discussion in partnership with APMM, the Association of Professional Model Makers. We have a great lineup. If you have questions at any time, feel free to put them in our chat or our Q&A, and we'll answer them in real time if they're relevant to the slide we're on. And of course, if we don't get to those questions, we will answer all of them at the end during our Q&A session. With that, I'd like to share a little bit about both of the organizations hosting this webinar today. For those of you who aren't APMM members, this is a fantastic organization and it's dedicated to creating a community of model makers. Some resources that it offers, if you're interested, are a member directory, employment listings, marketing and advertising opportunities, as well as conference discounts and more. B9 Creations is a global provider of additive manufacturing technology. It serves high precision applications in about 70 countries around the world in a range of industries, from model making, like all of you here today, to prototyping and manufacturing, medical, aerospace, research, jewelry, and more. And you can see some of the customers we serve on that slide here. I also want to give a shout out to the rescheduled APMM conference in Seattle. It will now be held this fall, October 23rd to 26th, and you can get more information on that conference at modelmakers.org. It's going to be fantastic. B9 Creations has attended several times in the past, and it's a really great way to connect with other model makers with a wealth of educational and resource opportunities there. Now for what you all are here for, I'd like to introduce our panelists. I'm just going to give a high-level introduction, and they're going to tell you more about what they do in their companies as we move forward. So I'll start with myself. I'm Danny Mason. I'm the marketing director here at B9 Creations. We also have Mike Smith, who's an additive manufacturing lead at a large corporate in-house service bureau working on product development. You can see Charles Overy. He's the director at LGM. Paul Chabala, he's our additive manufacturing lead at Crown Equipment Corporation, and Sean Anderson, who is the CEO of B9 Creations. With that, we'll get started. So let's kick it off with you, Mike. I know we have several large corporate entities who are currently in our audience, and they'll be very interested in your perspective. I'd love you to tell us a little bit more about your role, how you're using 3D printing as this additive manufacturing specialist in a corporate service bureau environment.
Thanks, Danny. So for my corporation, we generally utilize as much in-house services as possible to do our rapid prototyping. We like to keep IP in-house as much as possible, reduce costs, and speed up times between cycles. We also utilize our additive manufacturing processes to help improve current in-house systems, as well as provide assistance to other traditional manufacturing processes and industrial design processes. So not only for product development, but as well as boosting these other traditional manufacturing services to become better.
That's great. You know, I know one of the things that you have a great perspective on is how do you think about designing for additive manufacturing versus those traditional processes that you use in-house?
That's a great point. One thing that's very important is to remind people that additive manufacturing is a completely different process than what most people are trained in when they go to engineering schools and industrial design schools. It really opens up a new world of possibilities when it comes to design. If you do iterative design, if you do other types of non-traditional manufacturing where you can worry about things that have undercuts, internal geometries, a lot of different potential possibilities that traditional manufacturing doesn't really allow for. The other side that's good is that it can help not only replace certain functions, but also improve that traditional manufacturing process by utilizing additive manufacturing to quickly produce fixtures that can be used for traditional manufacturing, or quickly produce injection molding casts and whatnot. So it's a very good tool that can be used in conjunction with traditional manufacturing and not as a replacement. But breaking people out of the idea of that mindset that this is the only way to build stuff is a very important component of that.
So how do you do that? I'm sure you have people that everywhere from fresh out of college and maybe super steeped in 3D printing to very experienced engineers who grew up in more of this traditional manufacturing mindset. How do you reshape that way of thinking?
I think the way that we do that is by doing a solid system of education. We like to get people in a room together where we can have these older traditional ideas meeting with this newer ideas of how to manufacture stuff through additive, and then getting that conversation started. Really the only way to go about it that we found is to have an open line of communication between people so that those ideas can flow freely. Where we find issues is where people want to get stuck in their traditional ways, or that goes with additive as well, where you've only been stuck in that one mindset. So getting everyone in a room, or at least in some conference, to communicate properly is a really good way to kind of bridge those gaps.
Another thing that you've done really for your organization is serve as a champion of additive manufacturing. When you're in this large, dispersed corporate environment, there are many departments that want to incorporate additive, but they're not quite sure what all goes into that. How do you think about identifying champions and educators within a corporate environment, and then really bridging that gap between the technical user of the technology, the financial buyer who needs, a business case for it, and then those departmental requesters or outsourced providers?
That's a great point. I think it's really important to have that champion, because one of the issues that you can potentially find is with these larger corporations, you can have a large disconnect between the buyers, between the people that think this is what should be purchased, and then the people that would actually be utilizing the processes. In addition, you sometimes run into an issue that there's a disconnect between what people want, who's buying things, and then the people that are running it, and what the capabilities of those machines are. So having someone that can really take ownership of the entirety of the life cycle of the printer, from developing the requirements that are needed by communicating with the people that would make requests, as well as communicating with the people that would be purchasing the different machines, is a key component. That gap can serve as a big issue in the long run, where you can have machines purchased that are not necessary for the overarching goals of the company. You can have things that run a few times and then really you find out that it's overkill for what you need, or it's not quite enough. So having someone to fully own that process and keep an eye on everything about it is a huge component. There's quite a bit more that goes into additive manufacturing stewardship in a way than a lot of people might think. It's a fantastic technology, but it is time consuming. It does require quite a bit. Yes.
Danny, can I just ask a question? Mike, you said you had you look at it per champion for the printer. So you look at having a product champion for each technology that you bring in-house. So as you look at a new MJF, or you look at CJP, or you look at SLA, you're going to try and find a product champion for each one of those different technologies?
No. It's more of the additive manufacturing house in a sense. So for this, I would be, in a sense, for my lab, the champion for all of the additive manufacturing technologies, but that requires me to reach out to each of the different groups and see not just right now what the needs are, but potentially 3 years down the road, 5 years down the road, get kind of a roadmap for how these different projects and these different groups might change, and then integrate that with our own services, see what we can do to bridge that gap, see what we can do to add more functionality, add more tools to our tool chest, and then reach back out to their finance groups and our own finance groups to really kind of bring everything together. I think having more of a single entity that overarches and just does the additive completely is beneficial for us. Too many moving components can bring up that same issue before. So generally for us, I might have someone that once we decide on the technology, I push that person to be more of the on-site owner to run the machine. But the planning and progress and whatnot, I think generally comes from a single source.
Yeah, that's great. So coalition building, but have someone who really owns it end to end to help build that consensus and make sure there aren't missing gaps or silos. Yeah, that's fantastic advice. Okay. All right, that was excellent. So thank you, Mike. Paul, welcome. I'd love to hear from you how Crown is leveraging additive manufacturing.
Okay, well, so it's as we're leveraging additive manufacturing, really it's a supplement to our current manufacturing applications. Of course, like a lot of large companies we do our own design of product. We're very vertically integrated. So we've had 3D printers around for a long time, and they have been used in many different ways as we have grown in our design capacities. But now we're really starting to grow into truly additive manufacturing. And we're looking at it more now as an enterprise strategy. And I think that's a little bit of what Mike was alluding to with some of those connections and finding those people. And as you can see on the slide, it's really one of the downfalls of additive manufacturing is its own name. Because additive manufacturing, I have never believed is just a way to build things. Additive manufacturing is actually an enterprise strategy. And that's what we're trying to do now, is to incorporate it into all aspects of the enterprise, starting with design through production. It touches operations, accounting, and marketing in many different ways. And not just trying to find those individuals in all of those different aspects of the enterprise, but helping to get them to communicate towards that common goal. So that's really kind of where Crown is right now in our growth with additive manufacturing. So.
I appreciate that. I think it's a perfect segue. You recently had a role shift that really kind of exemplifies how important it is to treat this as an enterprise level function. You've gone to head of additive manufacturing now for the entire company. Can you talk a little bit about that evolution from maybe manager of a model shop to really elevating it to an enterprise function, and what the differences you started to see in between using it just maybe for rapid prototyping versus, like you're saying, true additive?
Yes, absolutely. So thank you very much. I did
yeah, congrats.
Start into the new position. So I used to manage Crown's product development, model shops, and their rapid prototyping. So we were heavily involved in utilization of the 3D printing in what you would call in that step process and getting to additive manufacturing. Obviously, we're doing a lot of rapid prototyping and design for eventual additive manufacturing, creating a lot of jigs and fixtures for the manufacturing front, but really kind of at that baseline. And that's where we really started to grow and get into that niche of utilizing 3D printing as it started to disperse its way out through the manufacturing aspect. And then we started to talk about, getting into supply chain evolution and talking into that next tier. And that's really where the break kind of happened, and which would kind of led my move from the model shops into the corporate leadership role. I definitely have more focus on the entirety of the business model, as opposed to just the design aspect of it and designing for manufacturing. Kind of my focus is kind of growing beyond that. So it's not just what used to be the addition of value to the product itself and the product design, really starting to look into the value propositions for the production process itself. Disrupting that supply chain and real future thinking and really where the value can start to explode even beyond just that new style of design.
I think that's greatly illustrative of how to use additive as a force multiplier. Has that shift affected how you think about which technologies that you use and how you think about applications of additive?
So absolutely, because really when we start growing beyond the product design itself and focusing really from the design first aspect and where it will lead you to the technology that you would then use to create the part. Really going beyond that and kind of infiltrating the front line of manufacturing and finding out where the sore spots are in that production process, and where can value be added in those applications, you know, beyond the actual product design itself, is really new to me. And it's something where I find a lot of new value coming from that. So.
Excellent. What I'd love to do is, you gave us a great real world example of how you've been using additive. Would you be able to walk our audience through the examples up here?
Yes, so a couple of good examples here. So one is our new D4 armrest, which has been released for our sit-down counterbalance vehicles. And, you know, I love being able to throw a product view up here, because a lot of people think, you know, Crown, you build forklifts, you know, they're big, heavy boxes of steel. Like, how is additive manufacturing going to possibly, you know, come into play with these things? And it's very shocking as to how much additive manufacturing is factoring in. So with the D4 armrest, it was really, that's a product that has a lot of modularity that's involved with it, because it spans our production line. So a lot of different trucks have this armrest that are going to go on it. So that control pod that you see on there actually swaps out with many different control pods. So you're really starting the additive manufacturing just bites right into that modularity aspect of it. And then really another interesting part is that when you think about where an operator sits on a forklift, you think it's big, you know, a couple of rails over top of it, and it's wide open. But in reality, for an operator, they're really in kind of a tight little box, and all of the controls have to fit around them. And really, so that design is not just so it, you know, looks nice and sleek. It actually is, we had to utilize the 3D printing in the design process and the prototyping process, and then have it move on into the actual manufacturing process, so that we can meet that volume control that needs to be in there. So that's one way. So you can, it allowed us to adapt quickly. It was a complex solution. We reduced tooling costs on that part because there was a lot more additive manufacturing parts as opposed to hard tooling on it. And the production volumes are low because there's many different versions of that armrest depending upon what the client needs. And then moving on to the automation fleet, really what we're doing there is we've taken our existing line of products, so they're more of a dual mode type aspect, where operators would normally run these trucks, but they can be switched over quickly to an automated version of it. So you're talking about taking the existing platform that we have in our vehicles, instead of radically changing them, just applying a lot of modifications that are necessary. And that, again, is where additive manufacturing has really stepped in and helped with that. And when you think about, it's the vehicle and the base platform, but every client has a different type of design or distribution center that these vehicles run into. So we can really help specifically, you know, focus the added extra design of the vehicles to each client. So
that's amazing. That's like all of the things you want to use additive for wrapped up in these two product examples. Thank you for that. All right, Charles, I would love to hear how LGM is using additive.
Well, we've been using additive since we bought our first machine from what was then Zcor, now 3D Systems, back in 2000. So we were early to the party. And we've grown up with additive what was first rapid prototyping and then 3D printing and now additive manufacturing. And I think as the terms have changed, the applications have changed. But we have used it really, you know, in 2000 we said, how can we produce more than one model every week or one model every 2 weeks? LGM is a traditional model shop. but I came from a technology background in aerospace and defense, and so we've always been technology leveraged, where we're going to select the best technologies that help us to produce our end product. So we're not a traditional service bureau in the way that some of the captive the big service bureaus are. But we do, send boxes out the door, and that's our product is the actual model itself. So we had to look at how do we scale, but still provide the absolute best quality product to our architects and to our designers, to our sales teams, and our museums and our other customers. And so when we look at various processes, we have CJP in-house, the follow-on to the Z-Core. We have 5 of those machines in-house. We have tremendous capacity in that. But we have very uneven demands in other technologies. So we still outsource, sometimes several hundred SLA models, traditional photopolymer, laser hardened photopolymer. But in order to do that, we had to bring small vat SLA, like the B9 printer, in-house because we needed to be responsive. And so I think the important thing to remember as you're looking at building a business case and how are other people doing it, is it's not an all or nothing decision. You need to bring in-house the technologies that are really, you can leverage and you can be experts in, but other technologies, you may still outsource.
I think that's great, talking about what do you bring in-house, what do you outsource? How do you think about the labor component of that? You having in-house expertise versus
that's all going to change. We made a decision last summer as we looked at what platforms we were going to purchase in 2019. And we said, we're not going to bring in large fat SLA. And we did it because we knew we couldn't hire people to staff that. And we didn't want to have that monthly nut of a big production facility. And SLA is big fat SLA is relatively inexpensive and it's relatively high quality. It requires, I think, Paul's going to talk about, or Mike's going to talk about environmental issues. You bring a big process like that in-house with great big factory floor machines, that's a big commitment. And we really didn't want to staff that. So we chose to continue to outsource that. But in order to do that, and in order to be responsive, we bring in some of the smaller desktop technologies, not the low-end desktop, not the home, but the middle of the road machines that are there now to complement those.
I think that's great. It's easy to think about in-house versus outsourcing in terms of technology, but really to think through the learning curve, maintenance, people side of it is critical too. So I'm really glad you brought up that point. I also want to give you an opportunity to talk through some real world examples where you've used additive. So would you share with our audience about these projects?
Yeah, so the house, the White House in the top left is very much our traditional product that we've been making for 25 years for architects all over the world. And this was really the case where I used to build these, like I think a lot of the people on the APMM, late night, all night, with an X-Acto knife. And that was what we really had to scale. And so we brought in, at the time, the Z-Core printer. I think this is Z-Core, but it has SLA windows. And we've really perfected the technology and the workflow that allows us to create these from the architectural geometry. And whether it's a small house model or a large industrial model, like the one below, the Ballston Quarter, that's really our bread and butter. What we've been doing a lot in the last 10 to 15 years, though, is also we realized we had an expertise in color printing that was fairly unique, and also in color. So we've been asked largely by other companies to do these types of sales aids, industrial aids, cutaway models, these types of things. So we've been producing a lot of those using several different technologies. We're excited about the Mimaki technology. We brought in MJF to do those, and we do production lines, short production of those, anywhere from 5 to several hundred, or actually in the case of Epson, several thousand aids that would be used in a trade show or sales environment. So that's something that has grown our business because of our core expertise in color and color rapid prototyping.
Excellent. Thank you. Okay, Sean, you're up. Can you talk a little bit about B9 Creations?
Absolutely, and I would apologize in advance if it looks like I'm looking away. I'm actually making notes because I love some of what each Mike and Paul and Charles shared and hit on some really key points that I'll circle back to here. You know, for us, as a company that manufactures this technology, I run into a lot of different expectations, everything from, well, are your 3D printers 3D printed? And, you know, as I think everyone on this call would agree with, you know, the answer is no. We do use additive manufacturing where it makes sense, but even for us, we recognize as engineers and production professionals that additive is a tool in the toolbox. It's, you know, I always use the phrase, you never saw a guy back up a truck to build a house with just one tool. You know, he has an entire truck full of tools, and producing a product or bringing a concept to market is very much the same. So for sure, we leverage additive and in everything from how we prototype components to how we iterate to, you know, those things like jigs and fixtures. We're getting ready to implement a new process in our manufacturing floor based around a new VAT technology. And one of our engineers, I was in here a couple of days ago, and he was in the back post-processing a bunch of weird looking parts. And I said, what in the heck are you making? And he's like, well, this new machine that we bought to utilize in our VAT production process, these little pieces, if I buy them from the manufacturer, you know, these things are 12 bucks a piece, and I just printed 10 that aren't their design, but work equally well to do what we need to do for about $1. And that's something that I think, I bring that up because as manufacturers, we have to realize that, you know, many people still live in the old world where if I can just sell them this product, then I'll sell them parts and service and kind of have them captive for years and years and years to come. And so when we think about what we do and how we use additive, we try and think about it from the perspective of how will our customers view the way they can use additive to interact with the solutions that our company provides. And that really starts with that example like I just shared of one of our young engineers. You know, the other example is we are producing, it used to be when you were going to tool up an injection mold part, you know, you try and do all the design reviews that you could, but inevitably it's almost impossible to anticipate every aspect of what the part needs to do. And then, oh, by the way, sometimes the design that optimizes what the part needs to do isn't very friendly to injection molding. And, you know, I've loved virtually everybody who's ever tooled up to injection mold something and then had to go modify the tool afterwards, raise your hand. I'm sure there are lots of hands up amongst our attendees, and you're not alone. We've been down that same road, but by, you know, using additive as that bridge between design concept and cutting a tool is a fantastic way to move faster and frankly save yourself money on tooling modifications and other things in the long run. And you know, the thing that you hear over and over when you talk about speeding up time to market, accelerating design cycles, the ability of, you know, our manufacturing team to actually build things with parts like what we envision the final product being, except these are additively made, and them coming back and say, you know what, I know you guys think this is a cool design, but this is a bear to manufacture, and let our design engineers, you know, go back to the drawing board, as the cliche goes, and not only thinking through from a marketing and a design perspective, but manufacturability perspective. You know, we're able to run tests in manufacturing based on additively produced parts that normally you'd be waiting for first articles off a tool. And unfortunately, at that point, now you're in a realm where you're going to spend money to modify that tool. Those are, you know, I've rattled off several here, but those are a few examples of how we're using additive inside our company, you know, week in and week out.
That's great. I'm going to put up a slide here so they can see what the young engineers are making additively. I also think it'd be great if maybe you could share a customer example of how they're using additive, potentially our customer in the UK.
Absolutely. And this is another one of those great, and please don't anyone misunderstand and think that I'm against injection molding. Not at all. We use it on a number of the components that go into the platforms that we produce. It's about being prepared to move to injection molding when the time is right. But we've got a customer in the UK that is now doing, production volume runs. And by that, what I'm using is that, we had a fun conversation I'll talk about in a minute amongst the panelists as we were prepping for this. When I say production volume, he's talking about 2,000 to 3,000 units, running them straight off of our additive manufacturing platforms, rather than tooling up or some other approach. And in our prep session, and forgive me, I can't remember who brought it up, but we were talking about this concept of production, low volume production, prototyping, and one of the other panelists very intelligently posed the question, what is the definition of production? And I think that is, it's changing as additive becomes more capable. And the ability to go to production, air quotes intended, before required, when you think about internally in your company, you've got to pass some quality, some regulatory, there are a whole lot of hurdles you've got to pass before you can move a product into production. What if you could start jumping those hurdles or those stage gates in your product release process using additive instead of final production, because your additive was so good at the, I'll call it low to mid volume, that you could do those validations with additive. When you think about things like that in terms of speed to market, it's not just the engineers and the marketing team playing catch-ball. That's part of it, but it's also given your quality and business improvements team parts that they can start going through the stage gate process with well before, traditional production volumes may have been reached. And, I don't know if it's appropriate to pause here, but I'm seeing the other panelists doing a lot of nodding. Danny, if we want to let anyone else chime in, that was a great conversation we had a couple days ago.
Yeah, absolutely. I think that, Paul, you're going to talk about it a little bit later as well, but do any of you guys want to chime in at this point?
Sean, I can jump in. I we'll speak to it later on, but you're absolutely correct in what we like to consider what's called the early adopter aspect of it. So there's many different aspects, especially when we're talking about some of our product line. They are very large, bulky pieces of machinery that go out, and there's a product development life cycle that it can be different for many different aspects of those vehicles and the platform. So a lot of time you're correct is that sometimes in order to fulfill the needs of the customer, because we're talking about fleets of vehicles that may be going out in time for huge distribution centers, and we need to get those vehicles to them quickly. So we'll do what's called an early adopter aspect of it, where we'll use the additive manufacturing in order to get the platform to the customer so they can enhance their distribution centers. And then we'll just update that platform as we roll online with all those aspects. So the point that you were bringing up is absolutely correct.
Thank you, Paul. Excellent. Mike or Charles, did either of you guys want to chime in on that as well?
Yeah, similarly, I completely agree. We've utilized some of our low volume production machines, specifically SLS machines, to help bridge that gap before we have to go into full production, where we can do production grade materials and really get full functional models out the door that work properly in the environment that they're supposed to be working in, to validate the designs, validate the processes that are going to be used on that assembly of that model, and validate the function of the model itself before ramping up full production to go large scale with it. So completely true that additive is very useful in that sense of bridging that gap.
I think the only thing I can add to that is that one of the machines we have in-house now, one of the new technologies, has a great number of additive manufactured parts, and you can tell where that selection criteria was made: complex manifolds, transport manifolds, metal, as well as nylon parts. And you can see live when you're working on the machine and doing all the maintenance, lots of maintenance that has to be done to keep this thing running, which parts were chosen to be additively manufactured. And I don't think that those are pre-production parts. Maybe it is with this machine. But I think that they're actual decisions given the volumes that they're expecting to make of this machine, to actually use additive in the final production machines.
It's a great conversation. I do want to also take another pause here and launch our first poll. You heard all about how these folks are using different additive capabilities for different applications. I'd like to give our audience a chance to respond where they see opportunities for using additive manufacturing in their own business. And while that poll is running, we did have a question come in that I'd like to give panelists a chance to answer. With additive, is there an advanced process for low/mid-volume, high-mix manufacturing scenarios? Do any of you want to tackle that? you're all
that sounds like a power question.
Do you want to give it a shot, Paul, about how you're doing a low, mid-volume, high-mix manufacturing with additive?
Oh, that's so. Yeah, I guess I'm trying to wrap my head around it between the low high mix. It's really because usually at a certain point in time we're trying to steer in a direction at that point in time. So when we're doing a low to high volume mix, really we're trying to, what I read that is, what we do internally is an iteration release, so to speak. If we're going to move towards a direction where we want to do multiple iterations or aspects of it, then I'm going to steer towards a low volume and additive manufacturing solution. If I'm going to do a large volume additive manufacturing solution, I'm going to steer towards iterating in such a way that's bringing out the value of additive manufacturing. In a sense, it's parts or product that cannot be created with the traditional applications of it. So, there's a differentiation factor in there. I guess it kind of, when you start talking about throwing volumes into the mix, specifically in additive manufacturing applications, as opposed to replacing injection molding, then it becomes a steering factor as to the directions that you're going on. I don't know if that answers the question.
Yeah, that sounds great. And I do just want to share our poll results as we go through our next section about what to consider with 3D printing, in case you guys want to speak to any of these. So it looks like the biggest opportunity is rapid prototyping and accelerated design cycles, followed pretty closely by manufacturing and assembly tools like jigs and fixtures, education and training, and then inventory on demand, design freedom, and the last part around customized solutions for customers. So that's kind of what our audience is seeing as opportunities. Okay. So I'd love, oh, go ahead.
Yeah, no, I think that's the perfect segue into this slide.
I think so too.
Because you just asked, if we look at how do we want to leverage additive manufacturing as a business tool, and where does it fit into your current process? Where does it fit into your process, as people are trying to suss out their crystal ball, which just got shaken up like a snow globe, over the next 6 to 12 to 24 months. I think it's very important to look at what are you really selling, and that's the answer to the question, the poll that you just asked. So if that's a design aid, don't get wowed by the technology into thinking that you've got to invest all this technology to scale manufacturing if you're doing design age. If you do want to manufacture, then you're looking at different machines. item 2 is to look at the process flow and make sure you understand, as you look at your upstream and downstream customers, where is the data coming from to solve this problem of what are you selling? Because again, it's easy to purchase a machine, and particularly as you look at multi-material machines, as you look at color, as you look at what types of material you're going to adopt, you need to understand that it's not just a technology. It's an ecosystem that surrounds the technology you're choosing. And how does that fulfill or grow your current value proposition as a business?
Mm-hmm.
So you don't want to just, you don't want to be either undermining your current profitable areas of business, or causing too big a shift that's going to make people don't overpromise the technology really. How are you differentiated? This is basic ideas of business. How is adding 3D printing or additive manufacturing into your shop or office or business really going to set you apart from the competition? And as we enter into a much more competitive environment, as we come out of the great pause, I think really looking at, how does this make my project look better, my building look better? How can I communicate better to my customers? That type of question is going to be really important. And then the final item I think is really important is, if you've used a service bureau, or even if you've tried to justify this in-house, as an industry, we're fixated on cost per cubic inch. And that's how we're used to pricing, and that's how we're used to seeing this. And I think that while that's a helpful way to evaluate and to draw a baseline, it does the industry a disservice to look purely at price per cubic inch, either in an internal cost justification or even when you're purchasing a part, because really you're not buying cubic inches. You're buying quality, you're buying solutions to the problems that you or your customers have. So really think who's going to provide the solution, either as a vendor or a service bureau, or when I go in-house. Maybe Mike gives you a cost transfer of several $1,000s, and you're like, oh my God, that's way too expensive. Well, what's the solution that Mike's actually providing? Not just the cost per cubic inch for that single part.
I think that's great to think about how to leverage additive as a business tool when you're considering adding or upgrading or outsourcing your 3D printing capabilities. And that's a really nice transition point over to you, Mike, to switch from business to what are the technical and regulatory considerations? How do I sort through this sea of tech specs and figure out what the heck this machine can actually do? Could you talk a little bit to that? Oh, and I think you're muted, Mike. Hang on.
And let me take myself off mute.
There you go. Oops.
And we're good again?
Yep.
All right. That's a very important thing to discuss, actually. Depending on the city that you live in and the municipalities, certain systems are not regulated. So for us, we ran into an issue a few years back where we wanted to implement a DMLM machine into our facility. And in order to do that, we had to reach out to the fire marshal, we had to reach out to our EH&S team, we had to reach out to the building owners and whatnot, because there were massive amounts of regulation that went into setting up a system like that. So looking into what the capability, what you're able to actually implement in your own building is very important when sussing out what technologies you want to add and what's good to keep in a vendor situation. That's something definitely that if you're a large enough company where you have an EH&S team, environmental health and safety team, that's the conversation you should start with them before you get into the purchasing component of these machines. A lot of these machines have a hazardous material component, either upstream or downstream. The raw materials for a lot of these photopolymers are has waste before, and then a lot of the byproducts are has waste. So setting up a full stream of has waste management is a crucial component of that, and that's a conversation that you and your EH&S team really do need to have, because it's not a great feeling to get through 30%, 40% of purchasing a machine and setting up a new lab, and then hearing halfway through that your EH&S team is going to have issues with, and you have to change your complete direction. So reaching out to municipality to see what the regulatory issues are, as well as your own EH&S team, is a very crucial part of the initial planning phases.
Yeah, I think that's great to mention the waste streams. You know, we talk a lot about hidden costs of 3D printing, and you can't just think about the technology, you got to think about post-processing and software and all of that. Could you speak a little bit to how to figure out those capabilities and that kind of that full life cycle of those machines?
Definitely. So I think one thing that's important for that is, for even before you start printing parts and whatnot, having software set up for STL file management and fixing components based on what design software has been used is a first initial step. We at our company have people that use everything from Rhino to Creo to SolidWorks and all these other CAD processes, and each of them deal with STLs a slightly different way based on the way that they're generating their geometries. So certain files are produced where in a CAD system they look great, but for 3D printing it's not going to work, based on inverted normals, separate shells, overlapping triangles, all these different things. So having a software system to properly intake those different CAD files is one component that's crucial. I feel like having a wide range of tools in your tool chest, as we've talked about, for all these different processes is also important. It allows you to have quite a wide range of freedom for the different requirements that are needed to be solved. But with that, each of them generally has their own waste streams. They each have their own post-processing techniques that need to be used. And each of those post-processing techniques generally have their own byproducts as well. So for instance, like SLAs, using some sort of IPA or denaturing bath solution to get the uncured material is important, and that's going to generate a waste. That also generates a fume that you need to have a fume hood for. Things like polyjet materials and jetting technologies, all of that material has waste beforehand, and the byproducts also need to be handled as such. So a full discussion with the manufacturers about what is fully entailed with each of the processes is pretty important. There's definitely a large amount of behind the scenes work that's done for the additive manufacturing processes that really can shake the grounds of what you thought you had set up. It's not necessarily going to be a $5,000 machine that you put onto your desk, or $50,000 or whatnot. Generally, setting up a full lab to properly process all these things, getting your full PPE, and having everything set up properly is really important. But a good way to also find that is getting in communication with a great community of people that use the machines, people that have lots of experience and can talk into their hardships and kind of their techniques to get around some of these other harmful wastes.
Yeah, that's fantastic. And then we're going to circle back here to a question we had earlier about what is the definition of production in this age of additive. So I'd love to get, I know you shared some of it, but I'd love to get some more of your thoughts. Paul, is there still this line between prototyping and low volume manufacturing, or is it all short run?
Yeah. Well, so Sean brought it up earlier. I see what is this changing definition of production in the age of additive manufacturing? Really, it starts to look at the change in the life cycles of the products out there. There was traditionally there was a basis of what the determined life cycle of the product was going to be, and designing towards that goal. And really, we're starting to see, because of the new technology coming out, those life cycles are actually shortening to a degree. largely because we're in the age of, as you pointed out, in Industry 4.0, we're in the age of big data. And really that's driving rapid adaptation in design with constant feedback coming from this. And so manufacturing, new manufacturing is really about adaptation. So it's, and how can you use the existing manufacturing processes and the new technologies in order to keep that adaptation going. And then with the line between prototyping and low volume manufacturing, there's definitely still a line, obviously, some of which has been touched on by both Charles and Mike. There's qualifications and standard applications that go into it. Obviously, when you're starting to look about product, going out the door, as opposed to the rapid prototyping or the design aspect leading up to it. Not that they're not important or that it's not taken into consideration at that point in time, but really you're crossing that threshold then once the product is going out the door. So even if the volumes are coming down due to additive manufacturing and different aspects of rapid adaptation and everything, really there's still some qualifying issues that need to be considered. And then, another part between prototyping and additive manufacturing, utilizing 3D printing, there is a lot of software out there right now. And Mike was, touching on this, on having the correct software in-house in order to lead to value with additive manufacturing. So you're starting to see a lot of generative design, being implemented in aspects. But there's also a lot of simulation software that is really getting very good. And so it's starting to cut into some of that prototyping aspect of it, because you can really simulate very, very well now. So you're seeing a little bit of reduction of even the physical manifestation in rapid prototyping, although again, that's not going to go away. So there's some new things that are in this Industry 4.0 that are definitely changing.
I think, Paul, there's a question from Mitchell on the Q&A. Do you think more widespread adoption of additive manufacturing will bring about just-in-time supply chain for large and very large production volumes? And I think this question fits right here, and I think it's very appropriate to look at, how did additive manufacturing respond to the COVID crisis? Because I think that's a fascinating real-life global case study of will we be additive manufacturing for large and very large volumes. And I think that the question is very complex. I think that the answer has to take into account, can it be done ecologically right now? And I think that there's a problem with the amount of energy that has to get put into an additive manufactured part as opposed to traditionally, say, injection molded part. That said, when you also put in length of supply chain, the sensibility of supply chain, I know everybody's looking at the face masks, right? And there's a lot of sort of online banter about, is it better to a face shield? Is it better to 3D print a face shield? Is it better to laser cut a face shield? Is it better to injection mold a face shield? But I think also the swabs case is really fascinating. Using these small desktop photopolymer machines, millions of test swabs, I think they're getting stuck up people's noses or in their mouths, I'm not sure, are getting manufactured. So this is a case where maybe it's not more economical, but the supply chain was broken, or you needed local distribution very, very fast. You couldn't afford to ship overseas, or you couldn't afford to have very centralized manufacturing of these millions of swabs. They needed to be at point of use. So I think the answer is, in certain cases, large or very large is possible. Yeah. But again, it has to be balanced by the amount of energy you currently have to put into a 3D additive manufactured part versus traditional manufacturing, and how that balances as we come out of the great pause, how has supply chains been disrupted? What is local manufacturing? How green is local manufacturing as opposed to distributed or highly centralized manufacturing? So I think the answer is it's going to happen, but we also need Industry 4.0 to mature.
And not to tip my hat to for future conversation that we'll be having, but you're correct, Charles, in the sense that the amount of energy going into the additive manufacturing part is definitely a consideration of it. But I know in an instance like with Crown that is very vertically integrated, so we're producing a lot of our own parts and components, and we are spread out globally in our manufacturing efforts. So when we start looking about implementation in a large sense, even for large parts, and being more on demand, we're talking about a significant reduction in the total sustainability footprint of the parts. So even with that large energy input going into it, and that can cause people to cringe initially, but when you take a step back and you start looking at the total sustainability application that you're looking at, sometimes that can shrink down significantly. It's not the same for all components, it's something to investigate, but it is, an instance, because there could be a very large sustainability footprint that you're trying to remove.
So Paul, do you see Crown being having distributed manufacturing in each one of their markets, where you're actually making end-use parts, not only replacement parts, but actual production parts distributed, so to reduce the risk of your supply chain as well as make it greener?
Yes, so there is definitely an aspect to that. Obviously, where our production is spread out globally because our product differentiates due to different global standards, and we have a lot of markets that we're in. So it is better for us to produce certain product in certain areas of the globe, although we do try to have a cross representation of those base parts that go across the product line. So we do share across those manufacturing lines. You try to find that balance that's involved with that. Now, if we go into and say, now we want to introduce additive manufacturing into that application, now it allows us to reduce that cross-pollination even more by having that part on demand within each market. And then even taking a step back from that, then we start to relieve ourselves of the necessity of having to duplicate the parts across the product line, because we can get a little bit more specific to the product itself, because there's some freedom that's involved with that. So it starts to nibble away at different aspects of it when you start implementing it in there. But yes, even for large production applications, we look at part on demand is definitely a factor.
They commented too and said, I didn't really think about the logistics side. Local additive production seems like a very good economical use. So it was good that we had that conversation. Paul, I don't know if you want to touch on any of these points as well. You may have covered some of them, but anything that's helpful when you think about implementation of this technology?
Yes, so implementation, you'll excuse me because I'm going to steal some comments that were made by Mike and Charles earlier. Change management has been a real focal point here at Crown. We have very high quality product that goes out the door, and it's something that we pride ourselves on, and that comes from years of engineering experience and some very large aspects of stamping, welding, tooling. I mean, you think about big large metal boxes rolling around. They're very heavy. It takes a lot of engineering to go into that. So when we start disrupting that type of design process, then we need to make sure that we're having a transition in the thought process that goes into it. And really, we start to look at some of the younger engineers that are coming out of school. They're being taught these processes right off the bat. So it's kind of the student teaching the teacher kind of aspect that we're looking at and bringing in some of these new technologies. Whereas it used to be that there was a lot of experience coming from the top down. Really, we're trying to filter some of that knowledge from the bottom up. So it's a little bit of a give and take, and that takes a little bit of change management. You know, when we start, you know, obviously the point of, you know, trying to figure out what makes sense in your situation for additive manufacturing. A very vertically integrated company like Crown, there's a lot of different areas where additive manufacturing can come into play. So we want to make sure that we're finding that low-hanging fruit in order to bring additive manufacturing in, get the success, and then scale up from there as we start to mature ourselves involved with that. And then transferring knowledge. I always use the story of the riverboat captain as opposed to the pilot, and I use additive manufacturing as the product as it's going down the river using additive manufacturing. There's really that one captain that's trying to drive that product from design to, you know, getting out the door. But there's many pilots along the way that pilot that riverboat along the way. And that's that knowledge transfer, is to know that each one of those individuals, each one of those components that's going into it, it's important for them to have the knowledge and the basis to get the product moving along the process, and having that oversight, and make sure that enough of the knowledge is getting transferred across the whole process, but still have that specialization where it needs to be. So that's kind of when we talk about that knowledge transfer. And then, you know, of course, designing with the production process in mind. So DFAM, making sure that you have internal quality control measures, even though there may be some existing standards coming online for additive manufacturing. And that's to make sure that you're meeting your own standards, your own product standards. Again, Crown holds ourselves to very high standards. So we want to make sure that we're developing that as well. And then what success looks like in 1, 3, and 5 years, really it's to start looking at what are the new successes that we're looking for in our product development, and then backfill that with AM, as opposed to say, well, what do we want AM to be in 1 year? What do we want AM to be in 3 years? Because it's just changing. The technology is changing too fast. There's no plateaus. There's no keeping up with it. So figure out what you want your successes to be, and then make sure that additive manufacturing is changing continuously, and you're feeding that in order to meet your goals.
Thank you, Paul. Sean, are there any other business, technical, regulatory considerations that you want to call out to the audience to think through?
Well, I wish this webinar was about 3 hours long, because the rest of the panelists have shared some nuggets that I think are just really golden for anyone who's working their way through this. And, you know, as we think about the business piece, you know, I want to circle back to something that Paul also mentioned earlier about the enterprise level strategy. And from a business standpoint, again, we have this tendency to think about, you know, internal customers, so marketing and the product development team. But what we need to be thinking about is how are we being more value to our end use customers? How are we more responsive to them leveraging additive? And I see so many times where people have invested a lot of money to bring additive into the company and really optimized around the internal consideration and not taken the broader strategic view, and left a lot of the value of additive on the table, unfortunately. You know, for sure, and, you know, Charles also brought up, in this whole context of COVID-19 response, I see a lot of people throwing the regulatory piece to the wind a little bit, and it makes me a little nervous. And I've fielded a lot of emails and phone calls about, you know, print this, print that, do this, do that, and at B9 Creations, we try really hard to focus on being the lean business methodology, additive manufacturing experts. We're not doctors. We're not a medical device company. We are not air filtration experts. There's a bunch of things we are not. But if we can partner with the right company and understand what does the customer need, the customer understands what level of filtration do I need, what kind of test does this, if you're talking about a mask, does it seal? I've been on some calls with people that had facial hair like mine who were really concerned about mask sealing. And I said, well, are you going to shave? And they said, no. And I said, well, then it doesn't matter because it isn't going to seal anyway. And I don't mean to be flippant about that, but I just want to drive home the point that, it's a little bit like the concept of Kickstarter, right? Where in the old days you had to, access to capital was really difficult. And so a lot of ideas didn't make it through. With the advent of a crowdfunding platform like Kickstarter, now we've really democratized the process and a lot more ideas get access to capital. But if you look at the stats on Kickstarter, the majority of those ideas never actually deliver the product because frankly, the pendulum might be a little too far over here. And we got ideas that really aren't baked out there gathering capital. Additive, where I'm going with this is, in the old days, well, if you couldn't wait 6 months and spend $500,000 to tool up, you didn't build it. Now we have the ability to make it fast and responsive and all of those things, but so many people are asking the can we question and not the should we question. And I would just encourage people to really not just think about what can we do, but what should we do with this tool. As has already been made pretty clear, additive is one tool in the toolbox. And even within additive, you have multiple different technologies, multiple different scales, and there are frankly lots of tools within the additive toolbox.
Thank you. I know we're running a little over time here, so we're going to keep going. I'm going to launch another poll, and we'll go through our next section rapidly as we can. So this poll is going to be, we asked about the opportunities. This one's going to center on the challenges when implementing additive manufacturing. So I'm going to let that run, and we're going to start talking about, now that we know what the applications are and the considerations, how do we tie all that together and really build a business case for additive manufacturing? So I'd love to kick it off with you, Mike. I know that one of the conversations you have with folks is, how do I know whether to use you as a service bureau, an outside service bureau, bring it in-house myself? What type of technology should I use? Can you walk folks through kind of how to think about that?
Yeah, sure, definitely. For us, generally, whenever someone reaches out about interest in adding a new additive manufacturing platform to their own lab, one of the first conversations I have with them is, what is your end goal? What is the use case that you're really trying to achieve with this platform? And what is your goal, as many of the other panelists have said, over the next 1 year, 3 years, 5 years? Because many of these systems have applications that are going to be evolving over time, and many times, as we've all mentioned, there's not one proper tool for all of these different issues that they might have. Generally also, I, if possible, try to lead people away from installing a smaller machine into their own offices within our company, because we've already gone through the regulatory systems and setups. We've had all of the EH&S, the waste stream management, and everything set up within our lab. So at that point, having the conversation about what their use case is and what their goal is, and seeing if we can help them implement that within our own systems or improve the current systems that we have to solve those needs, I think is a little bit more valuable. Because again, one thing that many people don't realize is unless you're doing the hobbyist style machines or whatnot, a lot of the larger machines have much more involved processing than just it's taking up this much volume in your lab. All of the other components of it require quite a bit of space and power, and you definitely have to consider all of those. So having the conversation, when you get that full understanding to people that might not be in the rep prototyping additive world and giving them the understanding of everything that's involved really helps shape that conversation to get that idea of what is it that you need, what is it that you're willing to do yourself, and how much of that you want to push to the lab that's already doing those kind of processes. Because again, there's, on top of just running the machine, there's regular maintenance, there's service that needs to be done, there's calibrations that should be done pretty regularly to keep everything to that high standard of quality. And then also balancing the cost of having a machine on site, not just with the sense of the overhead costs, but also what you are potentially missing out on by having that machine in your lab versus having another machine in that same space, if space is limited, as many people have. So that balance between what you can do in-house with, is it necessary to have a large bed FDM machine for the 5% of parts that you're going to be running that need that full volume, versus having a larger quantity of smaller base machines and outsourcing those, 3 or 4 large parts to a service bureau that you have an NDA and connections with. Those are all good conversations, that planning and that roadmap of what are you trying to achieve, that short-term goal, that long-term goal, and how can we align that goal with other issues that other teams are trying to have. But that conversation is a hugely critical thing. We've had people in the past where they've gone to a trade show, they've seen something that wowed them. They saw a Ldm machine and they thought, wow, this is amazing. We can produce these small metal parts quickly ourselves in-house. We don't have to worry about machining them, whatnot. But then when we get into the real conversation of what it takes to do that, the regulatory issues that we talked about before, having to register with fire marshal, having to register with the ATF because you have powderized metal, having to register with your EH&S team for those waste streams, and then the requirements it takes for someone to run that machine really showcase the reasons why we don't want to have something like that in-house for our situation, where that kind of machine would be better utilized as a vendor service. And we can use that same large footprint to put in, say, an MJF machine or an SLS machine that really would tie in what the needs are better. So having that full kind of education and understanding of what the capabilities of the machine are, what the requirements of the machine are, and what the use case are in a full conversation is a critical thing. Because certain machines also, is it worth it for you if you have a full access to a machine shop? Is it worth it to go through the time to set up a metal print that you have to worry about doing a couple iterations of different orientations to get support structures proper, to get a lower amount of post-processing on those bottom surfaces? Or is it better to utilize your traditional in-house manufacturing and utilize outside vendoring to solve those similar issues? But that entire ecosystem of what goes into doing this in-house and whatnot is a conversation to have. Definitely steering people to the correct outcome. So.
That's a very helpful framework for thinking through that. I'll share some poll results as we continue too. So some of the biggest challenges, I understand that it wasn't multi-choice selection, but I'll go through what folks have selected. Equipment costs rose to the top, lack of in-house additive manufacturing resources, materials and senior level buy-in were the biggest ones, followed by inconvenience of replacing legacy systems and a learning curve among the workforce. However, there was a good subset of the group that said we are implementing and growing constantly and we're not facing any of those challenges, which I love to hear. So good work on that. We'll go ahead and in that poll for now. And I'd love to give another perspective. This was actually, Paul sent us in an email and I said, that's the slide right there, the entire thing. So I'd love for you to shed some light on how you are supplementing 80% of your vertically integrated production process with additive.
Yeah, so yeah, it's interesting because when you're that vertically integrated and even with some horizontal applications to it, it starts to, there's many areas where you can start to filter it in. So I really tried to use the kind of a standard AM implementation and scaling factor. People may see that in a lot of different presentations. Is you're looking at the product impact on one hand, and then you're looking at the supply chain impact on the other hand. and you're going to see growth in both of those directions. Supply chain, obviously talking about the digital inventory, moving towards digital inventory, distributing the manufacturing, looking for ways that you can do that. Parts on demand, you know, really how can you reduce some of the traditional tooling aspects of it. So there's just, again, trying to find the pain points within the supply chain and find where impact can happen and continue along that path. The secondary path then, obviously, with the product impact, now you're starting to talk about implementation in the design, going back to the beginning and say, how are we designing for additive manufacturing and moving along that growth scale? And that factors into a lot of when you're 80% plus vertically integrated, obviously your production aspects and, you know, runs the gambit, whether you're casting, stamping, you know, anything like that in traditional mindsets, or even the electronic components that we produce ourselves. Then it's going to start to filter into the design changes that are going on there. So then just making sure that you're growing along those two paths, and then eventually that's going to come back together into a business model evolution where both the supply chain impact and the product impact are going to coalesce back together, and you're going to find that's when the value is really going to start to grow in there. So it's kind of when in an 80% vertically integrated situation, you want to disperse it as much as you can, finding that low-hanging fruit, continuing along those paths, and then allow it to coalesce back into the ultimately a better product at the end of the day.
Mm-hmm. Excellent. Thank you, Paul. Charles, you had two interesting questions here. One was not just how do I think about what to bring in-house versus service bureau, but when do you become the service bureau because you have all of this additive capability? Could you talk a little to how you think through those aspects when you're building a business case for a printer? Oh, and I think you're on mute, Charles. Hang on.
Sorry, I'll keep it.
There you go.
Sorry about that.
Okay.
I think that there are, when you look at what to bring in-house or what do you outsource, there's, you know, for a business, there are these small and mid-range machines that are sort of, to me, a no-brainer, and might take some contest with this, you know, whether you want to put the source of production close to the designer or not. I would argue that, you know, if you need it fast, if you need to iterate in 24 hours, or less with some machines these days, and you don't really care about quality, and it's a machine that you can put on someone's desk, and it doesn't have to run all day, every day in order to pay for itself, and it has low environmentals, then I think that almost engineers and designers are starting to expect that, particularly the kids that come out of school that have had one in their dorm room or had one at the lab down the way. And there is a tangible benefit to being able to touch it. But if you expect the best quality, if you've got to put this part in front of your customer, if you expect, you know, more than one or two off of that machine, if you expect repeated parts, if you expect people not to get distracted by the production flow, by all of these software issues, by all of the other issues, then you want to look at outsourcing or centralizing in a lab. I think that there are some hidden costs that are important. You've got to look at uptime. You've got to make sure that your vendor can provide the uptime guarantees, and it's really demonstrated in the field that their machinery can and will function under pressure, that it's not gonna choke when you need that machine to produce. I think that there is too much single sourcing in the industry right now too. I think that many vendors are locking you into supply chains with their materials and their software that is raising the cost beyond what is practical. So I would look, as you look at solutions, at least mainstream solutions that are more open than not, or that can be flexible. So.
That's great. And we actually just had a comment here, kind of a comment question that I think actually, Sean, speaks really well to this customer case. Ernest is asking about a challenge around printers, build size, and printing speed. And I think this is a great batch production versus single piece flow type of conversation to have. And maybe you could talk about this particular customer that we have up on the slide and how they thought through that process and centralized manufacturing and what that looked like for them.
Absolutely. And, you know, I'm certainly building on a number of comments from Mike and Charles and Paul previously here, but, you know, it's amazing to me when people think about, you know, additive manufacturing, that they tend to want to like throw out the Bible of manufacturing, which is lean production methodology. And they say, well, what I need is just, if I had a printer with a build area about the size of a football field and I could make 400,000 parts per build. And I'm like, actually, that's a terrible idea. What you want to look at is obviously is throughput, and think about, you know, how do you optimize when you think about cycle time, tack time, and the entire workflow, not just the printing piece, but post-processing, you know, cleaning, curing, whatever other post-processing goes along with the technology you're considering, and thinking all that through. We worked with a customer and are still working with this customer recently that has about 900 locations around the US, and they were being pitched very hard to build a many million dollar centralized additive manufacturing facility. And I asked the CEO, and I said, so when you have built that facility, how will you get the parts from that facility to all of your different locations? And he said, well, probably FedEx. I said, so you want to spend $50 million and at the end of the day still be dependent on what time the FedEx guy picks up? And he kind of cocked his head a little bit and was like, well, what do you mean? I said, well, why don't you produce where you need the product and then leverage, because obviously post-COVID, this is a little bit different consideration, but he mentioned one of their big challenges was workforce. And I said, you know, leverage your strong locations from a workforce standpoint for things like design and QC, et cetera, but produce wherever you need it. And frankly, when we think about turnaround time in this particular industry that I'm referring to, you know, same day is a big deal. And I said, well, you know, if you had design done in New York, you know, if a customer could come at 5 o'clock in California and say, I need this tomorrow. And if you had the design done in New York and printed locally, you could do that without paying any overtime just by leveraging the time zone difference in your organization. And so, and it comes back to what Paul mentioned earlier about really thinking of it from a strategic standpoint rather than just an internal, how am I going to make the part standpoint. You know, I've got a number of notes here of other things that I'd touch on. I know we're a little crunched for time, but I would just plug for anyone on this webinar, one of the real treats for us is how much we learned from doing the prep. I'm sure that my panelists would agree that, you know, the prep session we had was a pretty invigorating conversation. If anybody's interested in doing this, you know, reach out to us after the webinar and we'd be happy to bring some of your expertise into the conversation. But that's really, it's leveraging that ability to produce where you're going to use the product. And the topic of sustainability came up earlier. When we think about the environmental footprint of just shipping, and I'm just going to pick on plastic for a minute, but shipping plastic around the world, it's mind-boggling. Now, Mike's done a great job of helping us be aware of the EHS related considerations to, you know, I'm not advocating that you plop a desktop resin printer on every desk. There's ripples in them. If you went to do that, there would be ripples in the pond from an EHS standpoint. But if you, and I think Charles had already touched on this, but it's choosing a technology that has requirements that match your end-use production site's capabilities, right? Don't put some big powder-based system that, you know, requires specialized electrical and dust filtration and, you know, HVAC considerations and all this in a tiny little office that's basically has an outlet. not a, you know, that one seems obvious, but you'd be amazed at how many people don't think through, you know, the infrastructure considerations in EHS when they're mapping this out.
That's great. And then I just wanted to, if you could talk a little bit about this tool. It's a spreadsheet that, you know, we can help you put this together, but we use it ourselves to really put dollars and cents behind not just upfront costs, but ongoing operating costs and time savings. Could you just talk through this a little bit, Sean?
For sure. And, you know, based on who you told me was on the attendee list, there's probably a lot of them that don't need my help with Excel, because they're probably pretty good at Excel already. But oftentimes, and I think it was Mike that touched on, you know, there is this disconnect between the person who wants to use the technology and the person who is in charge of purchasing or maybe signing off on that capital acquisition request. And so this is just a tool that helps, you know, trigger, okay, what are the, you know, some of the obvious costs, obviously, but then some of the hidden costs that go along with implementing additive. Make sure you're picking the right tool for the right application, and, you know, walking through size and quantity and, you know, the value of time. It's amazing to me, the people, I've had a number of customers that told me that, you know, the question I love to ask is, what is it that you do that makes you money in your business? And what you want to do is obviously eliminate everything that distracts you from whatever that is. And, you know, whether you are, if you're an R&D engineer and you say that the way I'd create value in my company is taking these concepts and making them into producible, commercializable products, well, then invest in things that help you do that faster. Don't bring technology in-house that requires you to, you know, go through a 6-week training program to learn how to operate their 3D printing platform. Considerations like, you know, again, I was having a conversation with some people that were evaluating different technologies, and they were going to put a few hundred of these out in the field on a distributed basis. And I said, what's your preventative maintenance plan for those platforms? And the guy said, what? And I said, well, you know, who's going to calibrate, maintain, service? I mean, are you going to give your technology provider kind of a big contract, big annual contract to do that? He said, no, but what does it need? And that's what you should ask them, you know, because when you think about hundreds of locations, again, it's that can versus should question. Understanding what level of preventative maintenance is required, is calibration required, how often, how complicated, how much downtime does that introduce? There are all kinds of considerations like that that you just need to think through. I'm not trying to talk anyone out of using additive. I just want people to make sure they're really educated about what goes into the solution they're choosing.
Yeah, that's great. So we kind of wanted to wrap this up with, it was a lot of great information, but we're, as Charles said, in a great pause. And we want to acknowledge that and offer some tips with how each of our panelists have been working through this new environment and adjusting to it. So I want to start with you, Mike. You know, you had an almost entirely in-house production method, and all of a sudden you had to have a work from home mandate quite early on. Can you talk through how you went through that adjustment?
Yeah, actually we found ourselves in a pretty interesting situation. In California, we had the shelter in place mandate pretty early on. Before that though, we had a suggested work from home situation. And during that time period, we were able to leverage our in-house machines pretty effectively for situations where some of the production facilities that were happening in other countries that had been affected more during the beginning of this COVID situation, they were not able to develop the parts that we were doing, the fixtures for testing, and they also had issues with some of the injection molding tools that they had. So we were able to produce those in-house on our internal machines and ship those to the areas that needed them to bypass some of the supply chain issues we were having in that situation. But then once we also got the work from home mandate, we really had to leverage the supply and vendor network that we had created over the years for outside of the state vendoring systems and colleagues and whatnot. Luckily, we have set up some satellite labs around other facilities of our company, but utilizing that large vendor network and really leaning on our colleagues and partners has been a huge help for us.
That's great. And then I know, too, Paul, you kind of also experienced some supply chain disruption. Can you talk through how you guys adapted so that maybe our audience could benefit from some of the lessons learned?
So actually, what's interesting, and people don't think much about it, but Crown was identified very early as essential just because of the supply chain and logistics applications that we provide to our customers. So we had a lot of pressure on us that as the COVID situation started to roll out, we got a lot more pressure put on us to deliver. And so we were helping in any way that we could at that point, while people were concerned with printing masks and PPE device, which we were also assisting in that application. We were thinking we need to get trucks and vehicles out there so that the supply chain keeps going. And unfortunately, because we're so distributed globally, we do have facilities in Italy. We do have facilities in Germany. We have manufacturing facilities in Suzhou, China. So as the COVID scenario was rolling out, our supply chain was being disrupted greatly. And so what we were able to do was to utilize additive manufacturing in order to augment the product as it was rolling through, to make sure that our production was staying steady, and even though it was at a cost to us, so the cost factor wasn't there, but that's not what was necessary. The value factor was that we were able to keep our product rolling out in an essential time when it was necessary, and that was huge. That was really big. So.
Yeah. Absolutely. And I know, Charles, too, you saw some opportunity in this, a potential time to pivot your business model. Could you speak to that? And you are on mute, just so you know.
I don't think that, I mean, we're not pivoting, but I think I was reading an article that said, are you in survival? Are you in tweak? Are you in pivot mode? What do you see the next 6 months looking like? What do you see the next year looking like? And I think what's very exciting, I mean, it's time to start looking on the bright side and trying to look for the silver lining of this. And that is, Silicon Valley and a lot of people always talk about disruption and the power of disruption. It takes a lot of effort to disrupt a market. Well, we just, got the whole world put in a blender and shaken. So now is a great chance to have a pre-disrupted experience and to look at your business model and to say, what are the takeaways from this? What are the takeaways as people, if you're in the additive manufacturing business, are probably sending you articles every day. Look how the school kid made masks. Look how this company or that company responded. And a lot of it is hype and a lot of it is happy media, but a lot of it is real. And I think that in the first wave of media that we saw with additive manufacturing, we were all printing Yoda heads and, bottle openers and stuff. And I think what's going to happen now that's really exciting is we're back in the limelight again, but for having responded as an industry in a very global sense with distributed design, distributed manufacturing, and creating real solutions that actually save lives. And yes, some of it is hype, but a lot of it, I think, there's a little bit of how can you use that hype to reinforce your business, but a lot of it is very sincere, that I think people will be looking at the future at how do we de-risk our supply chain? How do we de-risk what we're doing? And I think there's some very exciting opportunities coming up in the next 6 months.
Yeah, agreed. Some wise words there. And then Sean, I want to give you an opportunity, not only how B9 Creations has managed through this, but we've also had a bunch of customers and suppliers and partners that are asking for help managing through it as well. Could you speak a little bit to that?
Absolutely. And, I love it when somebody other than me uses the Yoda head example. That's always my pet example of when I ask someone what they want to do with their additive manufacturing. And obviously, this whole COVID-19 thing is just it's an unprecedented, I would say, I don't know that the virus is unprecedented, but our globe and society's reaction to this is unprecedented, and the stresses that it's placing on businesses, our employees, our customers, our suppliers is just through the roof. So, you know, for us, we've looked at it as, obviously, we want to keep as many people safely working as we can, whether that's from home for the jobs that are suitable to that, or, you know, as Paul mentioned, there's, you know, forklift trucks might not be the first thing that came to your mind when you thought of a critical infrastructure industry, but only if you want to eat or do anything else with product that comes out of a warehouse, right? Paul gets it, but the rest of us who don't live in that world might not. So thinking about who's in my network and what can they do, one of the things, we have a partnership with actually it's a cable TV, satellite TV, internet service provider who said, hey, we need PPE. We don't want to dip into the medical supply chain. We want healthcare workers using, you know, if somebody has to use some DIY PPE, let it be us, not healthcare workers. And so we actually worked with them to understand, you know, the environments that people were going into, let them go research what requirements it needed to meet, how they wanted to achieve that, et cetera, and then figured out, okay, now additively, based on those requirements and their plan to achieve those, what can we provide them? And, you know, I would just encourage everybody on this webinar, you know, the worst thing we can all do is hunker in our bunker and give up. You gotta get up every day and keep swinging the bat, figure out a way to be useful and create value. And I'm not trying to give a corporate rah-rah speech. This isn't about corporate stuff. This is about all of us being in it and having each other's backs and working through the challenge to minimize, you know, make the best of a tough situation.
Mm-hmm. Yeah. And on that note, as we transition to our Q&A, I just want to again, you know, thank APMM for being such a great partner. And for everyone who's on this webinar, they're actually giving a free 30-day trial membership. So I would strongly encourage you to take advantage of that. All of our panelists, myself, we're all APMM members, and they're a fantastic organization. And then you're welcome to get in touch with B9Creations as well. You can see there where you can request a 3D printed sample. I am going to launch our last poll here. And this actually will let you connect with our panelists if you want to request more information from the organizations. So I'm going to launch that, and feel free to express interest if you have it. And on that note, I'm going to open it up to Q&A. It looks like we already have one Q&A. Are there any resins that don't have toxic chemicals? I don't know, Sean's unmuted, and we do resin 3D printing. Do you want to start?
I'm happy to kick that off, and I'm sure that there'll be a variety of answers. So one of the things that I would bring up in the answer to that is you always have to differentiate between in an uncured and a cured state. You hear a lot about, well, this material is biocompatible, that material is biocompatible. We offer biocompatible materials in the cured state. So I am not aware of a liquid photopolymer that in its uncured state is biocompatible. That doesn't mean that one might not exist somewhere, but as far as I know, you know, when I look at the SDS associated with every one of our resins or others that we've looked at in the marketplace, they all have certain precautions that you need to use. And I know that this question mentions reactions on their hands, and, you know, one of the standard SDS recommendations for most of these resins is wearing gloves. Now, you know, people say, yeah, but they printed a surgical drilling guide and it was right in somebody's mouth. And I said, yes, after it's cured and post-cured properly, you know, there's an entire workflow you have to follow to achieve a biocompatible state. And people like to toss around, you know, ISO 10993-5, ISO 10993-10. And the question you need to ask is, okay, what workflow was followed to achieve that? Not just the printing, but the cleaning, the curing, or other post-processing. So, sorry, that was a long answer to your question, but short answer is, I don't know of any liquid photopolymer that's biocompatible in its uncured state. And make sure that you understand the process they went through to get to biocompatibility in the end state. And I would open that up to, I see Mike doing a lot of nodding. He may have information here beyond what I do.
No, Sean, I would just say that I'm glad you said that, because when I first started dropping off SDS sheets a while ago trying to implement additive manufacturing, I was getting some cross-eyed stares. They're like, "What are you bringing in here?" And I had to make the exact point that you made. I'm like, we need to focus on the end cure state.
Yeah, Sean, I think you made a great point too, that in the uncured state, I don't know of either. I don't know of any that are non-toxic, but in the cured state, even when they're cured, like you mentioned, there are very specific post-processing requirements to make them accurately biocompatible. So we've run into situations here where people want to use certain machines because they have certain capabilities, but those are not, you know, proper to be used as long-term skin exposure type things. So that understanding of which ones are actually biocompatible, which ones, even in their cured state, shouldn't be handled more than, you know, a few minutes at a time, it's very important. Yeah.
That was great. Well, I don't see any more questions, but I do want to give you all kudos. A comment from Terry says, "Well done. This was a very informative webinar. All of the panelists were experts in their field. Impressive." So you can go put that on your LinkedIn bio. And I completely agree. I just want to thank you all for being panelists today. For all of you on the webinar, we will be sending this recording out to you, so you'll have it on demand. And we'll take these poll results that I see here, and I'll make sure that we connect you with the panelists that you want to be connected with, or APMM or Benign Creations. So with that,
I would
go
give
ahead.
one more quick plug for APMM. I would just tell you that that organization is so member service oriented, and the resources you get access to for what it costs to be a member, and being able to tap into the expertise of a ton of other people who have made things that would sound impossible and helping you solve tough problems. I mean, bang for the buck is just through the roof. And thank you so much to all of our panelists. I know you devoted a fair amount of time to do this and having a prep session and everything. I learned a lot from interacting with all of you. So thank you very much.
Yeah.
Thank you. Thanks for having us.
Yeah, thank you, everyone.
Okay, thank you, everyone. Have a great rest of your week.
Yay us.